All right, so the recording has started. So let's dive into today's lecture. Now, what we want to do today is in the last class, I hope you remember what have we done in the last class. If you go to your class tab, you would be seeing that like in the last class, we have discussed about decision tree classifier. And we started the decision tree classifier in the last class, where in the last class, we just gave a very brief introduction to what is a decision tree classifier. We saw some technical stuff about technical details about decision tree classifier in the last class, but we haven't yet finished the idea of decision tree classifier. So we'll finish our discussion on the decision tree classifier, the theory of decision tree classifier. Okay. And then what we intend to do today is I want to show you how to implement or how to apply a decision tree classifier. I will not implement a decision tree classifier from the scratch, but I will apply a decision tree classifier, okay, in a scikit-learn environment. Okay. All right. There is a machine learning library called scikit-learn, which I can use in Python. Okay. So I'm going to show you how to use scikit-learn to actually apply decision tree classifier on a particular data set. So today what I'm going to do is I'm going to finish off with the concept of decision tree. So we are very clear in terms of the theory. Okay, what does the decision tree do? And secondly, we would like to also apply the decision tree on a particular data set, and we're going to see what happens really. That's basically the intention. Is that okay, Nakina? Clear? Yes?
Yes, sir.
Are we good? Acha. Now, if you look at your classwork tab, you will actually see if you go to your classwork tab, you see there's a lot of topics here. The one of the topics over here is a data set. I guess there is a topic called data set. Here's the data set. I also uploaded in the morning one particular data set called churn raw data. Okay, so this is a CSV file. Okay, now I would advise you just download this CSV file. Okay, download this CSV file because today we're going to use this CSV file and we're going to apply decision tree classifier on this particular training on this particular data set. Okay, so just download it and we'll talk about this data set as we progress. Is that okay, Nakana? Are we good? Yeah, so do that. And meanwhile, I'm going to also open up my Jupyter notebook because let me open up my Jupyter notebook, go to the Python code, go to teaching, go to decision tree, and this is the decision tree classifier that we will use. Okay, this is the notebook. I'm going to just simply go to the kernel and restart and run all. You don't have to worry about that because it's going to take a little bit of time. So let it do its job. Okay, I let it do its job because it's going to take a little bit of time. ঠিক আছে? Okay, এটা কাজ করো. Meanwhile, এখন আমরা একটু let's go back to the idea of decision tree. Let's review some of the important things in the decision tree. ঠিক আছে? And let's discuss some of the things we did not discuss in the last class. Once we have completed this PowerPoint presentation, we'll come back and we will discuss how we can apply decision tree in a particular data set that we have. Is that clear, Nakana? Are we good? Yeah. Okay. Can you all hear me well?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So let's review a little bit about the decision tree that we have seen in the last class. Right. I hope you remember how does a decision tree look like, right, Nakana? Yes, this is how a decision tree looks like. Is that clear, Nakana? Yes.
Yes.
Okay, so we would like to see today how to build this decision tree from a data set. Okay, so we'll see that one. Now, I would like to remind you, we discussed this in the last class, but I would like to remind you again because we're going to see this issue today as well. Okay, so we're going to look at this issue carefully. Okay, and what is the issue? There are two very important design issues in a decision tree. Okay, so whenever you're going to build a decision tree, you will encounter two design issues, and we'd like to see what these design issues are. Number one, the first design issues that we have is how should the training records be split? This is a very, very important, design issue. How would you split the training set? Training records or training set. Like for example, when you split using the homeowner attribute first, then you split using the marital status attribute, then you went on and split with the annual income attribute, and so on, right? Obviously, the question is now, why did I do that? Why did we split using the homeowner first? Why not using the marital status first, right? That's an obvious question, okay? So the question is, how do we actually split? What attribute do we use to split? Okay, so you can have different decision trees based on how you're splitting, okay, but all of them will not give you the, will not give you a good result. So we would like to also see how to measure, or I would like to see how to evaluate the goodness of the test condition. কোন attribute দিয়ে আমরা যদি split করি, how good it is, how good the model would be, is something that we need to also evaluate. ঠিক আছে? So the first design issue that we face is how do we split the training records. ঠিক আছে? Okay, which attributes do we split the training record at every time we split? Okay, that's the first design issue we have. The second very important design issue that we have, and we will discuss about this one. We did not discuss about this one in details, but I think like when we're going to apply decision tree on a particular, training set, this particular thing would be much more clear. And the question that we have is, how should the splitting procedure stop? When do we decide, like for example, when do we decide that we do not go any further? It took for our further okay. One of the things that you could say is, as I continue splitting and splitting, the whole point of splitting is I want to make the data set more and more homogeneous. And when I reach an absolute homogeneous set, okay, that's where we stop. So for example, here all are no's and there is no yeses, so we stop here, okay. And over here, one of them is no, there is no yeses, so we stop here. Here 3 no's, 0 yeses, so we stop here. Here no no's but 3 yeses, and we stop here. ঠিক আছে? তার মানে if all the instances belongs to one class and no instance belongs to the other classes, that's where we stop. And perfectly the pure class distribution, that's where we stop, right? This is something we have seen. Is that right? Yes, মনে আছে? Hello.
Yes, sir.
Yeah, okay. Now that might not always be a good idea. Okay, so you could have two options. You could stop splitting if all the records belong to the same class. That means homogeneous sets or have identical attribute values. That's what we stop. That's one of the particular techniques which is illustrated here. Or the second technique is early termination. Early termination মানে কি? The termination এরকম ডিসাইড করা হলো যে আমরা এতটুকু ডেপথ অফ দ্য ট্রি হলেই স্টপ করব, বা এতটুকু ডেপথ অফ দ্য ট্রি হলেই আমরা স্টপ করব, উইল নট স্পিড এনি ফার্দার। Is that clear নাকি না? Yeah. So which one is better? Do we go for early termination? Do we go for do we keep on splitting until all the records actually belong to the same class? Okay, what we do. So there are two options here. Now it might seem right now that this is a better approach, but you would see that there are a lot of problems with this approach as well. Okay, so sometimes this is not such a good approach. Sometimes this might be also a good approach. So we'll talk about those sort of issues today. Okay, and we'll see how to deal with these issues. Is that clear, Nakina? Yes. So I would like to remind you, I would like to stress, okay, on the fact that whenever you're using a decision tree classifier, we face two very important design issues. Number one, how do we split the records? And number two, when do we stop splitting any further? Is that clear, Nakina? Are we good? Yes. And we'll see these answers as we start the looking into the decision tree classifier. Are we good so far, Nakina? Is that okay? All right, sir. একটু কথা বলতে হবে, otherwise I do not know whether you are understanding or not. ঠিক আছে? Okay. So I'll ignore all these things that we have discussed in the last class. And in the last class, I hope you remember that we discussed about how to split, right? Okay. And we discussed about, so the whole idea of splitting is this: whenever we would like to split, we would like to make sure that as we split, the nodes with purer class distributions are preferred, right, Nakina? That was our, objective, right, Nakina? And how do you measure the level of impurity? And we discussed that there are three ways we can measure the level of impurity. One is using a Gini index, then there's entropy, and there's something called misclassification error. But basically, we spoke about Gini index and entropy, right? Thank you. Yes?
Yes, sir.
Okay, so we discussed about these things. So what is the idea of splitting? So the idea of splitting is very simple. This is the idea. First thing what you do is before you split, find out the impurity, the level of impurity, how much impurity is. Okay, so compute the impurity measure before splitting. Now, how do you measure this impurity measure? Well, it depends. You can measure this impurity measure using either Gini index or entropy. You get it? Okay. I'm not talking about misclassification error because we have not yet discussed about that, right? Thank you. So you measure the impurity before the splitting. Second, you again measure the impurity after the splitting. Once you split, you measure the impurity, and this impurity M. So this impurity P is the impurity before splitting. This impurity M is after the splitting. But remember, this impurity M after splitting is the weighted impurity, right? And we discussed about what is weighted impurity in the last class. Do you remember that, Nakina? Yes?
Yes, sir.
Okay, so turns out that যত impure থাকবে তত কি হবে, তত এই impurity measure তত হাই থাকবে. So the point is split করবার পর এটা কি more impure হয় না more pure হয়? More pure হয়, right? নাকি না? Yes? Impurity level কমে যাবে. Is that clear, Nakina? Right? So impurity level কমে গেলে M এর value should be smaller ideally than P. Are we clear, Nakina? Is that okay?
Yes.
Yes. এখন কতটুকু কমলো? P minus M. This is the amount যতটুকু কমলো. এই amountটাকে I call it gain. So what we do is you can actually split it using different attributes. For example, if you look at here, sorry. If you look at here, you could have split it using an homeowner attribute. You could split it using marital status. You could split using this one. Now, যেই অ্যাট্রিবিউটের জন্য এই ডিফারেন্সটা যদি বেশি বেশি কমে যায় আর এই গেইনটা যদি বেশি হয়, ঠিক আছে, if the gain is very high, ঠিক আছে, p minus m এই ভ্যালুটা যদি জন্য বেশি হবে, that's the attribute that we will select. Clear, Nakina? Is that okay? Yes. This is something we discussed in the last class. I hope you remember. We're going to choose in the third section, we're going to choose the attribute that produces the highest gain, where the gain is the impurity before the split minus the weighted impurity after the split. Is that clear, Nakina? Yes? Okay. And then we went on to see this idea. So before splitting, you find the impurity level. Then after splitting, you find the impurity level for each of these nodes. And from there, you find that the weighted impurity. And then the gain would be then P minus M1 if you are using the attribute A. Okay. And it would be P minus M2 if you're using the attribute B. Then you compare between them. কোনটার gain বেশি, যেটার gain বেশি, that's the attribute that you use to split. Clear, Nakina? Is that idea okay? Yes. So these are the things we discussed in the last class. And last class we also discussed about Gini index. Okay, so remember the formula for Gini index, and I hope you remember these examples we discussed in the last class of how to use the Gini index to assess the level of impurity for in a particular node. Is that okay, Nakina? Mone ache? Yeah.
Yes.
Acha. So Gini index is one of them, and then we spoke about weighted Gini. This is a good example we have seen. So here's an attribute B, যেটা দিয়ে আমরা divide করছি. Now this is what happens before splitting. So you find the Gini value before splitting. Then after splitting, you have node N1 and node N2. You find the Gini for node N1, and then you find the Gini for node N2, and then you find the weighted Gini. ঠিক আছে? So the Gini before splitting is this 0.486. The weighted Gini after split is 0.361. So the difference between them, so that means Gini before split minus the weighted Gini after split will give you the gain, okay, which is 0.125. So I hope that example was also very clear to all of you. Is that right? Thank you. Now, yes. ঠিক আছে?
Yes, sir.
Okay, so we have seen all these things. Okay, Now I'm going to avoid all these things, and then in the last class we discussed how to use entropy. So we saw how to use Gini to do that, and we also saw how to use entropy to do that as well. This is a formula for entropy, right, Tekina? Yeah, and I think we saw these examples as well in the last class, right, Tekina? What else?
Yes, sir.
Yeah. So these are the things we have seen in the last class. Okay. Now the idea is the same. Okay, the idea is the very same using entropy as well. What do? Number one, you find that the entropy before split. So this is P. And then you find that the weighted entropy after split. So this is the entropy before split. Okay, before you make the split. Okay, and then after the split you will have different nodes, so you have to find out the entropy for each node, and from there you have to find out the weighted entropy after the split, right, Nakina? Yes. After split, and then if you find entropy before split minus the weighted entropy after split, that will give you the gain. Okay, in if you're using entropy as a measure, we call this gain as the information gain. Okay, or just call it gain. Is that okay? It's the same idea as that we as you have seen in the in case of Gini index. Clear, Nakina? Is that okay? Are we good? Hello.
Yes, sir.
Okay. Now, there is one particular problem that we have with entropy. And the problem that we have is if we have large number of partitions. Okay. Now, it turns out this is a problem with entropy. It turns out that node impurity measures tend to prefer splits that results in large number of partitions. তোমার পার্টিশন যদি অনেক বেশি হয়, স্প্লিট যত বেশি হবে, ঠিক আছে, তার গেইনটা তত বেশি হয়। লাইক ফর এক্সাম্পল এটা দুইটা স্প্লিট হয়ে যায়, এটা তিনটা স্প্লিট হয়ে যায়, right? Gender দিয়ে male and female, so it's 2 splits. There card type, families, post luxury, 3 splits. Customer ID, interestingly customer ID দিয়ে যদি স্প্লিট করি, যতগুলা রেকর্ডস আছে ততগুলা মানে স্প্লিট হবে, রাইট, নাকি না? So there's a lot of splits here. It turns out if you're using entropy, it will prefer this customer ID. But you know and I know that customer ID is not a very good, measure, right, Nakina? Yes. Okay, customer ID is not a very good attribute to split your data set with, right, Nakina? Yes, because customer ID doesn't tell anything about the customer. It's just an ID to actually locate which customer it is, right, Nakina? Yeah, is
Yes,
it
sir.
clear? But তোমার data set এ যদি customer ID থাকে, if you're using entropy, you will unfortunately see that customer ID will have the highest information gain. Okay, and as a result, if you're using entropy as a measure, as a way of measuring the goodness of the split, you'll see that it will prefer customer ID to split always. Okay, that's the first thing that it will do, but that's something we do not want it. Okay, so how do you actually deal with it? The way we deal with it is we, instead of information gain, we find something called gain ratio. Okay, and gain ratio is a very simple thing. Gain ratio is information gain. This is the information gain, right? Okay, now gains, that's the information gain. So what is this one? Gain ratio information gain. So this is the information gain, and you divide the information gain by something called split info, which is given by this equation. Okay, now the idea is তোমার যত বেশি স্প্লিট হবে তার split info value তত বেশি হবে. Okay, so who will have the highest split info? Gender, car, or customer ID?
Customer ID.
Yeah, so turns out the formula is such যে যত বেশি স্প্লিট থাকবে স্প্লিট ইনফো ভ্যালু তত বেশি হবে। তার মানে যেটা বেশি স্প্লিট করছে সেটা স্প্লিট ইনফো ভ্যালু যদি বেশি হয় তাহলে তার গেইন রেশিও কি হয়ে যাবে, কমে যাবে না, নাকি না?
Yes, sir.
Yeah, this is how we penalize যে প্রবলেমটা আমার এন্ট্রপিতে আছে, যেটা মানে বেশি স্প্লিট করে সেটাকে প্রেফার করে, I can actually penalize in that particular way. Is it clear নাকি না? Yes? ঠিক আছে? Is that fine?
Yes.
Good. Okay, so that's what we do over
স্যার
here.
আমাদের ইয়াটা কি হবে, গেইন রেশিওটা বাড়ানো না কমানো, মানে
স্যার ব্যাপারটা হচ্ছে গেইন রেশিও যত বেশি হবে, দ্যাটস দ্য ওয়ান দ্যাট উই উড প্রেফার। ঠিক আছে? ইজ ইট ক্লিয়ার নাকি না? ইয়েস? ওকে, বুঝতে পারছেন? গেইন
Yes, sir.
ভ্যালু যত বেশি হবে সেটাকেই আমরা প্রেফার করতে যাব, সেটাকে দিয়েই আমরা স্প্লিট করতে যাব, রাইট নাকি না? আর প্রবলেম যেটা হচ্ছে ইন কেস অফ এন্ট্রপি, আমার যদি স্প্লিট বেশি হয়, বেশি করে যে অ্যাট্রিবিউটটা, সেটার ক্ষেত্রে ইউনো গেইনটা বেশি হয়ে যায়। ইট প্রেফার্স ইট ইন দ্যাট ওয়ে, এন্ট্রপি দিয়ে মেশর করলে তাই হয়। ঠিক আছে? অ্যান্ড অ্যাজ এ রেজাল্ট, আমার যদি জেন্ডার থাকে, কার্ড টাইপ থাকে, কাস্টমার আইডি থাকে, ইউল সি দ্য কাস্টমার আইডি উইল হ্যাভ দ্য হাইয়েস্ট ইনফরমেশন। Is that okay, Nakina? Yes? Customer
Yes, sir.
ID has the highest information gain because it splits it so much. But you know, and we know, you all know that in customer ID, they split is it a good idea or not a good idea? It's not a good idea because customer ID is really an ID, right, Nakina? It's a data set thakai uchit na, tai na, Nakina? Yeah, it's an ID to actually locate which customer we are talking about. Is that right, Nakina? Yes? Am I clear, Nakina?
জি স্যার।
Yeah. কিন্তু আনফরচুনেটলি যদি কাস্টমার আইডি থেকে থাকে তোমার ডেটা সেটে, ইউ উইল টার্ন আউট দ্যাট মানে your entropy দিয়ে মেজার করতে গেলে it will always prefer to actually split the data set first with the customer ID. ঠিক আছে? But that's something we do not want, right, Nakina? Yeah. So basically what happens is খুব বেশি স্প্লিট যদি করে তাহলে সেটাকে যেহেতু প্রেফার করে, we do not want that as well, right, Nakina? So we want to penalize it in some way. So this is the way we penalize it. We find the information gain and we divide it by something called split info. And the interesting bit about split info হচ্ছে যত বেশি স্প্লিট করবে তত স্প্লিট ইনফো ভ্যালু তত বেশি হবে। তার মানে একটা জিনিস যদি খুব বেশি স্প্লিট করতে থাকে তাহলে স্প্লিট ইনফো দ্য ডিনোমিনেটর উইল বি সো লার্জ দেন সেটা গেইন রেশিওটা কমে যাবে। Am I clear নাকি না? So this is how we penalize the gain. Is that clear নাকি না? Yes?
ইয়েস
Hello?
স্যার।
Yeah. So that's the whole idea over here. ঠিক আছে? Okay. So here's an example over here. So you see over here card type. আমরা গিনি দিয়ে these are the গিনি values. ঠিক আছে? গিনি values এটা ঠিক আছে? Okay? Alright. এখন দেখেন এখানে এই কার্ড টাইপ কয় ভাগে ভাগ করছি বলেন তো? How many splits are here? 3. আর এই কার্ড টাইপে হচ্ছে ফার্স্ট কার্ড টাইপ হচ্ছে 3টা স্প্লিট। আবার যদি এইভাবে যদি স্প্লিট করি তাহলে কয়টা স্প্লিট করেছে?
2 ভাগে।
আর এইভাবে করে কয়টা স্প্লিট করেছে?
2 ভাগে।
Right. So if you calculate the split info using the formula that I have given you over here, that's the formula for the split info. You will see that আমি যদি 3টা স্প্লিট হয় like this, its split info value is 1.52. কিন্তু দুটো স্প্লিট হলে its split info is 0.72 and 0.97. তার মানে what it's showing is that split info will be larger if there is more splits, right, Nakina? Is that right? Yes? এখানে 3টা স্প্লিট হচ্ছে তার জন্য split info is larger, right, Nakina? Clear? Is that
Yes,
okay? All right. So that's what I'm saying. So in case when you have, a lot of splits going on here, then this split info will be larger. And if the split info is larger, then it will penalize the gain as the gain ratio will decrease. So that's what's going to happen. Yeah. Acha, now there is another way we can measure impurity, which is called the classification error. Theoretically, that's a formula. Okay, but we'll not go through this one. Because in practice, this is something that we do not use. And there is a reason why we do not use. I'll ignore it, but I'll not go through this one. I'll just tell you what happens in a 2-class problem. In a 2-class problem, আমি যদি entropy measure করি, y-axis এ entropy আর x-axis এ এটা probability আছে। Am I clear নাকি না? Yes? Okay? Hello? Are we good? Entropy formula কি ছিল মনে আছে? Minus sigma I equals to 0 to c minus 1, all the classes that we have, right? Do you forget this? Yeah, entropy formula key. 0 to c minus 1 pi probability into log of base 2 pi, right? Yes. So probability pi times log of base 2 pi. এটা ফর্মুলা ছিল না নাকি না? Yeah. ঠিক আছে? আচ্ছা, এখানে একটা এক্সাম্পল দেখাই আপনাকে। ওকে, টু ক্লাস প্রবলেমের জন্য, দিস ইজ ফর আ টু ক্লাস প্রবলেম। তার মানে দুটো ক্লাস আছে, একটা probability চুজ করি। লেটস সে উই চুজ আ probability of 0.5. Yeah. So if the probability is 0.5, তাহলে একটা ক্লাসে probability of the ith class is how much? 0.5. তাহলে what's the probability of the other class?
1 minus 0.5.
Which is also 0.5. 0.5. তাহলে what is the entropy going to be? Entropy would be minus একটা ক্লাসে probability is 0.5 into log of base 2 of 0.5. Correct নাকি না? Yes. ঠিক আছে, probability times log of that probability, right নাকি না? প্লাস অন্য ক্লাস যেটা আছে সেটা probability হচ্ছে 0.5 because 1 minus 0.5 is 0.5 into ওটা log হচ্ছে log of base 2 0.5. Clear নাকি না? Is that okay? Yeah. So can I not say this is minus 2 times 0.5 times log of base 2 0.5? বলতে পারি নাকি না? পারি না।
Yes, sir.
এটা একই জিনিস, তো 2 times that. So 2 times 0.5 কত? 1. Correct নাকি না? Yes. Yeah. Into log of base 2 half. Right নাকি না? There's a minus sign over there. Now log of base 2 half কত ছিল? What's that? That is equal to log of base 2 1 minus log of base 2 2. Correct? Yes. Now log of base 2 1 হচ্ছে 0 minus log of base 2 2 হচ্ছে 1. So this is minus 1. So what's happening? This is becoming minus 1 times minus 1, which is equal to plus 1. And you see when the probability is 0.5, then the entropy value is plus 1. Is this clear? Yes. I hope you get that. Right? So এভাবে যদি আমি probability different probability change করি 0 থেকে শুরু করে 1 পর্যন্ত, I'll get different entropy values, right? নাকি না? 0.1 এর জন্য একটা entropy value, 0.2 এর জন্য একটা entropy value, and so on. Is that right? নাকি না? Yes. Hello.
Yes, sir.
Is it clear? Sir, আপনারা দেখতে হবে এটা কি ক্লিয়ার হয়েছে? How did I find entropy for when the probability of the one of the classes is 0.5? Is that clear নাকি না? Yes. So in the same way, if I change the probability from 0 to 1, then it will have different entropy. And if you plot the graph of entropy against the probability, you will always get a graph which has a shape like this. Is it clear নাকি না? Yes.
Yes, sir. Yes, sir.
ঠিক আছে? So that's what's going to happen with entropy. ঠিক আছে? So if you plot the graph of entropy against probability, you'll always end up getting a nice graph like this way. ঠিক আছে? Okay. And that's actually interesting to see. Why is it interesting to see? তুমি দেখো probability যদি half হয়, what does that mean? What does it mean that the probability is half? Half মানে হচ্ছে two class problem. Remember, একটা probability half হচ্ছে half, আর একটা probability হচ্ছে half. তার মানে কি? Is it pure distribution or is it very impure?
Very impure.
Very impure. And in fact, you see that this has the highest entropy, highest level of impurity. Is that right, Nakina? In fact, you see over here, যদি এমন হয় একটা probability যদি 0 হয়, তাহলে আরেকটা probability কত? বলেন তো, একটা ক্লাসের probability যদি 0 হয়, আরেকটা ক্লাসের probability কত? 1. তার মানে
100.
আরেকটা ক্লাস যেটা আছে সেটা সবকটাই ওই পার্টিকুলার ইনস্ট্যান্সেস, ওই ক্লাসের ইনস্ট্যান্সেস গুলোই আছে, তাই না? That means that's the most pure one, right, নাকি না? Yes.
Yes, sir.
So
Yes, sir.
most pure one has an entropy of 0. Okay. আবার এখানেও যদি probability 1 হয়, ঠিক আছে, তার মানে একটা ক্লাসে সব আছে, অন্য ক্লাসে কিছু নাই. That's also the most pure one, right, নাকি না? That also has an entropy of 0. তার মানে this is a very interesting thing to see as it becomes more and more impure. So if you increase the probability, it's getting more and more impure, ঠিক আছে, then the entropy is actually increasing. আবার এখান থেকে যদি বাড়াতে থাকেন impurity actually কমতে থাকবে, and that's why entropy value will start falling. Is that clear নাকি না? Yes.
Yes.
So as you go from 0 to 0.5, it's getting more impure. And as you go from the priority 0.5 to 1, it's getting more pure, right? And as it becomes more and more pure, you see the entropy value will be start falling. Is that clear? Yeah? Are we good?
Yes, sir.
It turns out Gini formula দিয়ে যদি আমি বের করি, Gini also have the similar shape. The only difference is the shape of Gini and entropy is same. The only difference is the value. Okay, the highest gain you can have with Gini is 0.5, and the highest entropy you can have is 1. Clear? Is that okay?
Yes, sir.
But if you use the other one, which is a misclassification error, which we haven't covered, you see that the graph will not be a nice concave shaped graph like that. It will be something like that, and that's something we do not want to use. Okay, we usually want to use impurity measure that would be a nice concave curve like this one. So the ones that are like entropy and Gini. Is that okay, Nakina? Clear? Okay.
Yes, sir.
Yes, sir.
Now, I hope now it's clear why do we use entropy and Gini? Because you can see as it's more pure, the values of entropy and Gini are small. As it becomes more and more impure, the values of entropy and Gini starts increasing. Okay, and as it becomes more and more pure, then the values of entropy and Gini starts falling. Am I clear, Nakana? Is that okay? That's why in the last class we did not discuss. We just have given you the formula for entropy and Gini, but now you see because of this nature, okay, entropy and Gini are good impurity measurements. Okay, so we use these two formulas or these two concepts to actually measure the level of impurity in a particular node. Is that clear, Nakana? Are we good?
Yes, sir.
Yeah,
Yes.
so এটা clear. আচ্ছা, we're going to stop here. So আমি এখন আর ভিতরে ঢুকবো না. I will not go into misclassification error. We'll stop here. Okay. Now what we want to do, এই যে এত কিছু করলাম আমরা, ঠিক আছে? I want everybody to pay full attention right now. Okay. I want to use the idea of decision tree classifier. Okay, right? In order to actually, let's say on a particular data set, to actually see what happens. ঠিক আছে? আমরা একটা decision tree classifier use করতে চাই on a particular data set. Are we good? Is that clear? Yes. Okay. It's a classifier. Decision tree is a classifier, right? So you can use this classifier to actually, on a particular data set to actually make some prediction, right? Is that okay?
Yes, sir.
আচ্ছা, so এখন আমি চাই everybody to pay full attention. ঠিক আছে? Full attention. So because this is extremely important. So I'm going to get started. ঠিক আছে? Okay. So I'm going to start with this Jupyter notebook. So I've already opened the Jupyter notebook. I don't want you guys to use any Jupyter notebook right now. I want you to see what I'm doing. ঠিক আছে? Okay? All right. So all the codes are there, but I'll go through each of these codes that we have written over here, and I'll explain you what exactly happens. Is that okay, Nakina? Clear? Is that okay?
Yes, sir. Yes,
Okay.
sir.
Now, I am not going to, so this is the first thing. I am not going to build the decision tree from the scratch. We already have libraries, so we will be using a machine learning library to actually use the classifier from there. Is that okay, Nakina? Clear? Are we good? So last time, remember a baseline classifier আমরা scratch থেকে build করেছি. Right now, I'm no longer going to build from the scratch. Okay. Rather, I'm going to use a particular machine learning library to actually use the classifier. শুরু করব নাকি না? Let's get started. Yes?
Yes.
Okay.
Yes.
Now, the first thing, we're going to learn a few things today. Number one, I hope to finish that. I thought of starting it a little bit earlier, but anyway, let's see how far we go. Okay. So what's today's agenda? We have a few agenda today. We are going to read a CSV dataset using pandas. Now, this is something you already know, that we know how to read a CSV dataset from using pandas data frame, right? এটা আমরা জানি. Now, once you read the data set, it's খুবই important that before you use the data set, before you use any kind of classifiers like decision tree, k-nearest neighbor, 1R classifier, whatever you want to use, before you use any kind of classifier, it is a very important thing to actually have a sense of what is the data set about. So what we're going to do now here is I'm going to apply different exploratory data analysis technique, EDA. Okay, so we can explore the data set in different ways, and we will try to understand what the data set that we are dealing with. Am I clear নাকি না? So যে কোনো data set এ আগে classifier machine learning apply করার আগে you need to have a good sense of what you're dealing with. Am I clear নাকি না? And that's where we do the EDA or exploratory data analysis. Okay. Now, depending on the data set, you may need to pre-process the data set. You may need to do certain adjustments to the data set, right? There could be outliers. You need to know how to handle outliers. There might be, missing values. Then you need to know how to tackle these missing values. Okay? Then there could be, categorical data, but you may need to convert it into numeric data. How do we do that? Okay. Then last time আমরা যখন k-nearest neighbor করেছিলাম, we spoke about scaling, তাই না নাকি না? Scale করা, right নাকি না? Feature মনে আছে নাকি না? So how do we scale them? So all these things are pre-processing techniques. We do pre-process so that the data set is now in a bit better shape for the use of machine learning techniques. Okay, so we are going to apply different pre-processing techniques to pre-process the data set. And then what we're going to do is we are going to apply a holdout validation technique. So we're going to talk about that, what's holdout validation technique. Okay. And then we are going to use the scikit-learn. This is a particular machine learning library in Python. We're going to use the decision tree classifier from the scikit-learn library to train as well as to evaluate the performance of the data set. Is that okay, Nakina? And finally, we are going to discuss the issues of model overfitting. I hope we will be able to complete the entire thing. Okay, so let's see how far we go. Okay, so what's going to happen here? Okay, so this cell, I'm just going to run it, but I think this is so we haven't done anything, but I'm just going to give you a sense of what's going to happen. After you apply the classifier, you should be able to create a decision tree like this. Okay, so it's a decision tree na naki na?
Yes, sir.
Yeah, so we will learn how to build a decision tree like this. Okay, so hopefully that's something we're gonna do today. Okay, so let's get started. Shuru kori আমরা. Okay, so all these a Jupyter notebook will be made available to you guys, so that's not an issue. So I want you to actually go through this one with me right now very carefully so that you understand what we're doing at each stage. Okay, so let's get started. So before we start anything, we need to load the different packages we will be required. So we'll require certain packages. We'll load these different packages that we have. Now, what are the different packages we have imported here? First of all, I've imported something called NumPy. Okay, I have imported pandas because I have to read the data. And I'm going to use also matplotlib and seaborn because I need to draw some plots and stuff like that. So we usually write %matplotlib inline if we are using a Jupyter notebook. Okay, I think even if you do not write it, it's not a big problem. But that's it. So we have imported the basic libraries. Is it okay? So we've imported the NumPy, the pandas, the matplotlib, and the seaborn. Is that okay, Nakina? Yes? Okay?
Yes, sir.
Yes, sir.
We have done a few things here, but if you do not want it, do not do that. এগুলা like precision কতটুকু হবে, 2 decimal place, 3 decimal place, যখন in case of your SNSC bond যখন আমরা ড্র করছি, setting the RC parameter the figure size of 8/6. so যখন আমি একটা figure plot করছি, the figure size is 8/6. so these are the initial kinds of different kind of formatting. If you want, you can put it. If you don't want, you may not put it. That's okay. Among there are some more libraries. এখানে কিছু library maybe we do not require them, but it's just here. So এই paragraph যে library গুলো আছে, you can just ignore them. এখানে দেখো there is a certain interesting library. এই লাইব্রেরি গুলো হচ্ছে যখন আমি scikit-learn ইউজ করব, যে scikit-learn ইউজ করে decision tree classifier ইউজ করব, সেখানে কিছু libraries we have imported like scikit-learn.preprocessing থেকে we have used something min-max scaler. Min-max scaler দিয়ে ওই যে আমি বললাম না স্কেল করা যায়, you can scale a particular feature, right? বললাম না একটুকে? So actually rather than writing a code for that, I can use a min-max scaler to actually, convert it, and I'll show you how to do that. তারপর what we are going to do today is we are going to use something called holdout validation technique. You can বলেছেন না? We are going to do today something called a holdout validation technique, right? নাকি না? Yeah? Yes? So
Yes, sir.
what's a holdout validation technique? Holdout validation technique is something that you already know, but let me just show you. In Weka, when you went to Weka, আমি আপনাদেরকে একটা জিনিস দেখিয়েছিলাম. Let's say for example, you go to Weka, you go to the Explorer tab, okay? You open a file. I'll just open any file right now. See program files. I think Weka. Just let me just open anything. Okay, it doesn't matter. I don't know what's that. I'm just open that. Okay, we go there. Let's say we go to the classify tab. এখানে classified tab করলে ট্যাবে গেলে there is 4 test options, তাই না? First test option থেকে using the training set. Using training set অপশনটা কি করে? Any idea? এটা হচ্ছে যেই ট্রেনিং সেটটা আছে সেই ট্রেনিং সেট দিয়ে ট্রেন করে এবং ওই ট্রেনিং সেট দিয়েই টেস্ট করে দেখে কত, রাইট নাকি না? ক্লিয়ার?
Yes, sir.
ওকে, এন্ড তুমি যদি এটা দাও সাপ্লাই টেস্ট সেট, তার মানে যেই ডেটা সেটটা তুমি এখানে ওপেন করলে সেটা ট্রেন সেট, এন্ড ইউ ক্যান সাপ্লাই আ নিউ আনসিন টেস্ট সেট অ্যাজ ওয়েল। ঠিক আছে, দ্যাটস অলসো সামথিং পসিবল। ইজ ইট ক্লিয়ার নাকি না? ইয়েস? ওকে। There's a third option called the cross validation. We'll talk about that sometimes later, not today. And there's a fourth option called percentage split. What is this percentage split going to do? কি করে সে?
তার কত পার্সেন্ট মানে 20
Yes,
কত
that's right.
Right.
percentage
It's going to take that data set that I've supplied. কোথায়? I've supplied the data set here, right? It's going to take that data set and it's going to take 66% of this data. You can change this one. You can wake up that 66% is default. Okay, 66% of the data it will take it as a train set, and the remaining I think 34% of the data it will keep it as a test set. Is it okay, Nakina? Clear? Yes.
Yes.
Right? So then training set use করে ট্রেন করার জন্য এবং ওই টেস্ট সেটটা ইউজ করে টেস্ট করে ইভালুয়েট করার জন্য। Am I clear Nakina? Is that right? Yes.
Yes, sir.
This is what we call the holdout validation technique. এখানে যে আমি বলছি we are going to use a holdout validation technique. It's basically this one. Okay, so you're going to take a data set, you're going to split the data set into training set and test set, and I'll show you how to do that as well. Okay, now then you're going to use the training set to train, and then you're going to have your holdout valid test set that you're going to use to test and see what happens. Is that clear, Nakina? Yes.
Yes, sir.
তার মানে আমরা যখন ট্রেন করব we are not going to use the test set to train. Test set is those data that it hasn't seen before, right Nakina? Yeah, is it clear so far? So good, Nakina? Hello, ঠিক আছে? Do you understand this, Nakina? Yeah, কথা না বললে তো অসুবিধা।
Yes, sir.
Yeah, so we're gonna use this thing. So we're gonna use something called min-max scaler to do feature scaling. So then scikit-learn a model selection বলে একটা জিনিস আছে, ওখান থেকে we're gonna import something called train test split. We're gonna use that to actually take the data set and divide the data set into train part and test part. আমরা manually কিছু করব না, we have the libraries for that. ঠিক আছে, so we're gonna do that. This is a tree for decision tree, and this is the decision tree classifier. This is the tree to draw the tree, but anyway, this is the decision tree classifier. Then we have something called, we can calculate accuracy score. We have something called confusion matrix. All these things we can do for different sorts of things. So anyway, we have imported all these things. ঠিক আছে? Now at this
স্যার এই
point,
যে ওইখানে ইম্পোর্টটি এটা কি আলাদা একটা অ্যালগরিদম?
কোনটা
tree-
এটা ট্রি?
জি,
ট্রি
স্যার।
হচ্ছে এই যে তুমি যে ট্রি ড্র করছো এটার জন্য।
ওকে স্যার।
Okay, এটার জন্য এই ট্রিটা ইম্পোর্ট করতে পারো। Is that clear নাকি না? Yes. Okay. But in any ways, then if you don't have GraphViz, I would recommend you to install GraphViz. using something called pip install graphics. ঠিক আছে? We'll see what's the job of a graphics later on. ঠিক আছে? So we have done all these interesting things. Okay. এটা হচ্ছে আমার একটা machine learning process. This is a diagram I've shown you earlier as well. Right, নাকি না? Yes? Okay.
Yes.
So what is this about? What are the steps that we're going to follow? Okay, so first thing is we're going to do a problem formulation. Problem formulation ta mane ki? Problem formulation mane hocche amra we're going to decide what is exactly our objective. We need to set our objective. আপনার কোনো অবজেক্টিভ নাই, আপনি র্যান্ডমলি করছেন, মানে দ্যাট মাইট নট বি সামথিং ইউজফুল, রাইট নাকি না? ইউ নিড টু সেট ইউর অবজেক্টিভ, রাইট নাকি না? So that's the first thing. We're going to formulate the problem. What is the thing that we are trying to solve? What is the thing that we are trying to predict? What is the thing that we want to analyze? ঠিক আছে? Okay, we're gonna set our problem formulation. ঠিক আছে? After that, we're gonna collect the data. Usually we collect the data. In your case, you're collecting the data through questionnaires. In my case, well, the data is already available. ঠিক আছে? So we are using an existing data set. Okay. Then we can do some pre-processing. We start with EDA, exploratory data analysis. We're gonna see what features are there. Okay, how many elements are there in part feature, if there is a null values missing data. So the whole point of EDA or exploratory data analysis is that I have a better understanding of what is the data set I'm dealing with. Is that okay, Nakina? So we're gonna look into the data set, we're gonna look into different things about the data set so we understand what we're dealing with, right, Nakina? Then of course if you require to clean the data, you're gonna clean the data. If you need to aggregate the data, you're going to aggregate the data. Many of the things you may not need to do because that might not be the purpose, and you do not do them. ঠিক আছে? You need to do some normalization and scaling if required. ঠিক আছে? You may require to convert your categorical features into numeric representations. Okay? Then you may need to do feature selection, although we are not going to talk about feature selection today at all. So we're not going to talk about feature selection and feature engineering, right? But most of the data pre-processing task is going to happen at this stage. That means after we have formulated the problem that you're dealing with and gathered the raw data, we are going to do data pre-processing. Clear? Yes? Now, because I say that we are going to do the holdout validation technique. So first of all, before you apply the machine learning model, you need to be able to split your data, right? So that's the next thing that we're going to do. We're going to split the raw data into training set and test set. অনেকে ট্রেনিং সেট, টেস্ট সেট, ভ্যালিডেশন, ইভালুয়েশন সেট এরকম আলাদা আলাদা তিনটা সেট করে। আমরা will keep it simple. We'll just split our data into training set and test set, and I'll show you how to do that. Then you'll take your training set and you training setটা নিয়ে এটাকে আপনি কি করবেন? মেশিন লার্নিং ক্লাসিফায়ারের উপর অ্যাপ্লাই করবেন। ঠিক আছে? করবার পর টেস্ট সেট দিয়ে কি করবেন? You're going to evaluate this one and you're going to actually produce the result. So এই প্রসিডিউরটা এখানে যেভাবে আছে, we are changing a little bit over here. So what I'm going to do, after we have split the raw data, okay, into train and test set, আমরা train setটা ইউজ করব, train setটার উপর decision tree classifier ইউজ করব to create a model, and we're going to evaluate the performance using the test set. Am I clear or am I not clear? Yes?
Yes,
sir.
sir.
So this is the entire procedure that I'm going to do. So hopefully আজকে যদি পুরোটাকে আমরা দেখতে পারি, you will have an understanding of যে প্রথম থেকে শুরু করে লাস্ট পর্যন্ত কি অবস্থা হয়. How do you do pre-processing? How do you split the raw data? How do you use a decision tree classifier on the training set? And then how do you evaluate using the test set? So hopefully we're going to see the entire thing. Okay, I know we have only how many minutes left? Maybe around 20 minutes left, but let's see. Let's try a little bit. Let's see how far we go. So the first thing we have to decide. So I'm going to follow this particular, methodology. Okay. Of course, we have changed the methodology a little bit in case of training and testing, but let's go. Let's see. So the first thing is we need to do problem formulation. What are we trying to solve? Now, I'll keep it simple. I would say that we want to predict if a customer will churn or not. That's the whole objective. Now, what do you mean by churn? Okay, let's look at that. I'll give you 1 minute time. Have you seen the data set? The data set that আপনাদের download করতে বলেছি, churn raw data. Have you downloaded the data set from your Google
Yes, sir.
Classroom? Yeah. So what I want you to do is I'll give you maximum 1 minute. just open up the data set and look at the data set, okay? And just have a sense of what are the things we have in this data set, okay? Is that clear, Nakana? Can you do that? Can you open up your Excel file? Yes? Okay?
Yes, sir.
And just look at the CSV file and just have a quick glimpse on the data set so that you know at least what are the things that we have over there or not. Yeah, can you do that? I'll give you 1 minute to do so. Actually, 40 seconds to do so. Quick, do that. Okay, have you done that? Did you open the CSV file and did you see what happens? Yeah?
Yes, sir.
Okay, let me do everything from Python. So you have opened your CSV file, but let me do it from Python. So the next thing that we're gonna do is we're gonna read the raw data from into Python using CSV. Sorry, what am I saying? You're going to read the raw data into Python from CSV file. Okay, so that's this part. Gather the raw data, but we're just going to, because we already have the raw data, we're going to read this one. So the way we do that, you know this one, we have discussed about pandas data frame. So pd.read_csv, and we give the name of this data set. The name of the data set is churn raw data.csv. Am I clear, Nakina? Okay, এবং I stored this in a data frame. A data frame to নাম কি দিচ্ছি? Raw data. Is that clear, Nakina? Is that okay? So here, raw data, raw_data is what? Is the pandas data frame. Am I clear, Nakina? Is that okay? Yes. I read the data and I store the data in a data frame called raw_data. Is that okay, Nakina? Are we good?
Yes.
Now don't tell me you forgot pandas data frame. Because we spent a lot of times on those sort of things before, right, Nakina? Yeah. So we read the data, okay, into the data frame called raw_data. And the next thing we do is we print the shape of that data frame, okay, and we also find the head. Head will give me the first 5 instances. Clear, Nakina? Okay. So if we run that, so let's see our observation. So the first observation we see is how many rows are there? Hello, how many rows are there?
10,000.
10,000 rows. So there's information about 10,000 customers now. Okay? And there are 14 columns. So let's look at these columns very quickly, because I put a head so I can see the first 5 instances. We have a row number, we have a customer ID, surname, we have a credit score, whatever the credit score may be, geography. So these customers come from different countries like Spain, France. I can see that. Maybe there are more countries later, because there are 10,000 instances and I'm seeing the first 5 of them. So I can see already there are customers from France and Spain. And their gender is taken. I can see all females here, but I'm sure there are some males as well. And their age is given. There's something called tenure is given. Balance is given, what balance they have, how many products do they have is given. Do they have a credit card or not? 1 or 0. 1 means they have a credit card, 0 means they don't have a credit card. Is the customer an active member? 1 means yes, 0 means no. Their estimated salary is given, and there's something called exited. Okay, 1 and 0. Now this data set is a churn data set. Churn data set is a very useful data set in your big organization. Churn data set মানে হচ্ছে অনেক কাস্টমার আছে না একটা পার্টিকুলার অর্গানাইজেশনের সাথে কাজ করছে, বা ইটস ইউজিং দ্য মানে ইটস টেকিং দ্য সার্ভিস অফ দ্য অর্গানাইজেশন, হঠাৎ করে মানে হি হ্যাজ এক্সিটেড ফ্রম দ্যাট এবং সে চেঞ্জ করে ফেলে অন্য একটা কোম্পানিতে চলে গেল বা অন্য কোম্পানির সার্ভিস নেওয়া শুরু করলো। Am I clear নাকি না? হয় না? Right? So you probably have been I don't know, just giving an example. Let's say for example you are using your internet service from a particular ISP, and after 2 years or 3 years, then or whatever, after 6 months, whatever the time may be, you decided you do not want to take the service anymore. you moved on to a different company, right? You took the service from the different company, right? Yeah. So if you move out, that's called you've churned from that particular company. Is that clear, Nakina? Okay. And for any particular company, this is a very important to understand who is going to churn, who is going to actually, move out. So we want to find out people who are actually moving out from us. ঠিক আছে? Because that is clearly something that is going to, you know, have an impact of the on the company's revenue. So a company is very interested to know that who are the people they're not being able to retain. ঠিক আছে? Who are churning out. So this is that data set about. ঠিক আছে? So the data set says this particular customer is churning out, this customer is with them retaining, churning out, retaining, and so on. Clear, Nakana? Is that okay? Yeah.
Yes.
Okay. So the next few classes, I'm going to use this data set to do different kinds of things. Okay? And you'll be amazed what kind of things we can do. Okay. All right. So it's very important that you understand that this data set. So this is okay. So we gathered the data set. We read the data set into your data frame. Is that okay, Nakina? Yes?
Yes, sir.
Now, once we have done, let's go to the data pre-processing step. So in the data pre-processing step, we're going to do a few things. First of all, we're going to explode the data set in order to have a good meaning of that, in order to understand certain things about this one. Now, I wrote a simple function over here, and this function will help me understand the data set a little bit more, okay? So you'll understand the code, so I'll explain the code. The purpose of this function is it will enable you to investigate all the elements within each feature. প্রত্যেকটা ফিচারের মধ্যে কি কি এলিমেন্ট আছে, we want to analyze that, okay? So the way we write it, for column in raw dataটা কি জানছিল? The data frame. ঠিক আছে নাকি না? Yes?
Yes, sir.
Okay. For column in raw data, ওই data frame এর মধ্যে যতগুলো for column in raw data, I'm going to find raw data column dot unique. Raw data column dot unique মানে কি? First columnটা হচ্ছে ধরো row number. Row number এ কতগুলো unique value আছে? That is what the dot unique one would give me. Customer ID তে কতগুলো unique value আছে? That's what it's going to do that. ঠিক আছে? So we are going to run a loop for each column. ঠিক আছে? For each of these columns. Clear নাকি না? So for column in raw data, তার মানে প্রথম loop করবে row number এ যতগুলো unique value আছে, it's going to take all the unique values and store it in unique vals. Is it clear নাকি না? Yes? ঠিক আছে? Hello? Is that okay? আচ্ছা. Now once it takes the unique values for each for one of the columns, okay, then we're gonna find the length of the unique values. কতগুলো unique values আছে সেটা calculate করলাম, and we put it in NR values. NR values means number of, okay, I mean number of unique values that we have. ঠিক আছে নাকি না? Yeah, number of unique values that we have. ঠিক আছে? Okay. If the number of unique values is less than 12, যদি 12 কমে unique values থাকে, we are just printing out the number of values for the features, okay? Then we are giving three things here. So তিনটা জিনিসের মধ্যে কি কি আছে? Column. So কোন কলামের জন্য, ঠিক আছে, কতগুলা unique values আছে এবং ওই unique values গুলো কি কি সেগুলো আমি প্রিন্ট আউট করে দিচ্ছি। Is that okay? আর যদি নাম্বার অফ ইউনিক ভ্যালুস যদি মোর দ্যান 12 হয় বা মোর দ্যান ইকুয়াল টু 12 হয়, এত ইউনিক ভ্যালুস আছে, লাইক ফর এক্সাম্পল কাস্টমার আইডি, মেবি প্রত্যেকটা কাস্টমারের ইউনিক ভ্যালুস আছে, ইটস নট মেকিং এনি সেন্স যে 10,000 কাস্টমারের সবকটা ইউনিক ভ্যালুস প্রিন্ট আউট করে, রাইট নাকি না? ওকে, সো ফর unique values greater than equal to 12, I'm just printing out the column name and how many unique values are there, number of unique values, but I'm not printing out what are the unique values we have. Is that okay? So if you run this code, okay, you can see at home what this code is doing. And you see for each of these columns, it has figured out. Row number A, there are how many unique values? What are unique values?
10,000.
10,000. Of course, because there are 10,000 customers, so there are 10,000 rows. ঠিক আছে? প্রত্যেকটা রোর জন্য একটা row number দেওয়া আছে, so there are 10,000 row numbers. এবং there are 10,000 unique customer ID. Of course, that confirms me right now that there are 10,000 customers. Okay. Out of them, there are surname যাদের আছে 2932 unique surnames. There are many other people who have similar surnames. Maybe they are from the same family, maybe not, whatever. But we have 2932 unique surnames. Okay, this doesn't tell me a lot of things, but some of this information will tell you quite a lot of things about the data. Some of the information doesn't tell you anything, but that's okay. That's why we say we're going to explore the data sets, see if we try to understand. Okay. Okay. Number of features, the number of values for credit score. Credit score quite a unique value. There are 460 unique values. Okay. Acha, geography a feature touch. There is a feature called geography, right? Yes. Here is a feature
Yes,
called
sir.
geography. Okay. Geography থেকে কতগুলো unique values পাওয়া গেছে? Interestingly, we find only 3 unique values, and because this is smaller than 12, it also prints out what are those unique values. So what are those unique values? France, Spain, and Germany. So what do we know from here? The customers of this company comes from 3 countries. What are those? France, Spain, and Germany. Am I clear, Nakina? Is that okay? Okay. Is that understandable? Yes.
Yes, sir.
Yeah. So next is gender. Well, there are 2 unique values, male or female. That's understandable. Age, there are 70 different age values, 70 unique age values. Okay. Tenure কিছু একটা, whatever it may be, there are 11 tenure values to 1. Actually এটা sorted ভাবে দেয় না, ঠিক আছে? So if you sort it, it should be 0 1 2 3 4 5 6 7 8 9 10. Okay. Balance, there are 6,382 unique values. Doesn't say a lot of things. Number of cards, number of products. So each customer can have 4 products. Either একটা product আছে, দুইটা আছে, তিনটা আছে, অথবা চারটা আছে. Has credit card, has 2 unique values, 1 and 0. Understandable. If it's 1, that means he has credit card. If it's 0, he doesn't have any credit card. Is active member. Feature টা হচ্ছে দুইটা unique value, 1 and 0. 1 means he's an active member, 0 means he's not an active member. Estimated salary, there are 9,999 unique estimated salary. Exited, 2 1 and 0. 1 means he has already exited the company. Okay, he doesn't use the service of the company. 0 means he's still with the company. Clear, Nakana? Is that okay? So it gives you a few information about these data sets. For example, I know that these customers basically come from France, Spain, and Germany. These are the 3 countries. It comes from each of the customers take 4 kinds of products, maybe. Okay, 1 2 3 4. I know that. Okay. So there's certain information I get from this simple, function, right? Nakana? Is it clear? Yes. Understandable?
Yes, sir.
Okay. Now, next one, if you go over here, rawdata.isnull.sum. What it's going to do for each of these columns you have, it's going to find out if there is any null value or not, if there's any missing values or not. But interestingly, we see that for all these columns that we have, there is no missing value. That's a good thing because we don't have any missing values, so we do not need to worry about missing values. ঠিক আছে? So if there is any missing values, we will have to deal with it. But right now, because there is no missing values here, we do not need to deal with it. Is that okay, Nakina? Are we good? Yes? ঠিক আছে? Are we good? আচ্ছা. Now,
Yes.
here, আমরা একটু যদি কি কলামস নামগুলো দেখতে চাই, ডেটা ফ্রেমের নাম হচ্ছে raw data dot columns দিলে, if I do so, it will give me all the columns that we have. Now, why did I do that? It's just convenient. Next cellটার জন্য, next cell আমি চাচ্ছিলাম যে কোনগুলো আমার ইম্পর্টেন্ট কি বলে feature values, সেগুলো আমি নিচ্ছি. So important feature values, like row number is not an important feature value. It just says what are the row numbers, right? Customer ID is a specific ID to, pinpoint a customer. That's also something not very important for me from the machine learning perspective, right, Nakina? Yeah. Surname, name, it's not so important to me as well. So, okay, credit score, maybe it's important. I don't know. I make a list of columns that I think are important. So credit score is an important thing. Geography, okay, I'll keep it there. Gender, I'll keep it there. Age, I'll keep it there. Tenure, keep it there. Balance, I keep it there. Number of products, keep it there. Has credit card, keep it there. Is active member, estimates the salary, exited. So I keep all of them and put it in a new list called my list. Am I clear, Nakina? Is that okay? Yes?
Yes, sir.
This data frame that we have it was called raw data. Now I'm creating a new data frame called raw data 2. Okay, and this raw data 2 is raw data যেটা অরিজিনাল ডেটা ফ্রেম ছিল সেটা থেকে এই মাইলেজ এই কলামস গুলো নিয়ে একটা নতুন ডেটা ফ্রেম তৈরি করলো। So this new data frame has less number of columns. Am I correct নাকি না? Yes, because I did not keep the row number, the customer ID and the surname, right নাকি না? Is that okay? Yes. So now we have a new data frame called raw data 2. So if I do raw data 2.head, if I run this one, you'll see this is how the raw data 2 looks like. So I do not have the row number, I do not have the surname, I do not have the what's that thing, customer ID. So apart from them, these are the important information that I think is interesting for us, is what I have kept over here. Am I clear, Nakina? Is that okay? Yeah. So far so good.
Yes, sir.
So what is this data frame called? This data frame that you have in front of you? What is it called? What's the name of the data frame that holds this information?
Raw data 2.
Raw data 2, exactly. Okay. Now, okay, the next thing that I'm going to show you, and there's a little warning here. Okay, there's a little warning to run this one because it can take a lot of time. So we're gonna visualize data. There's something called CPON and there's something called pair plot. Pair plot কি করে? প্রত্যেকটা নিউমেরিক ফিচারের সাথে প্রত্যেকটা নিউমেরিক ফিচার সে প্লট করে। লাইক ক্রেডিট স্কোর একটা নিউমেরিক ফিচার এগেইনস্ট এজ, ক্রেডিট স্কোর এগেইনস্ট টেনিওর, ক্রেডিট স্কোর এগেইনস্ট ব্যালেন্স, এগেইন আবার এজের সাথে এজের সাথে ক্রেডিট স্কোর, সবকটা প্লট করে। যদি তোমার অনেকগুলো কলামস থাকে, দিস মাইট টেক আ লট অফ টাইম। সো what I have written sns.pairplot, I take the raw data 2 and I put exited ta hoche is something that I'm interested in. Exited 1 0, right? That's the one I wanted to predict it, right? So I just kept it as a hue, right? As a categorical variable. I exited as a categorical variable because it's either 1 or 0. So hue is exited. Is that okay, Nakina? Clear?
Yes.
Okay. Now if I run this one, it's going to take a little bit of time. So that's unfortunate because pair plot takes a lot of time, and you can see it's running and running and running. Okay, and you can also see that this particular notebook is busy right now. Okay, it usually takes a little bit of time, so you need to use it with caution. If you have too much data, too much columns and too much data, maybe you need to be able to limit the data. যেগুলো important part, যেমন আমি এখান থেকে ধরো অনেকগুলো কলামস কিন্তু বাদ দিয়ে দিয়েছি। কেন বাদ দিয়ে দিয়েছি? এগুলো আমার দরকার নেই। আমি ওগুলো দিয়ে যদি করতাম, it's just going to take a lot of more time. ঠিক আছে, already see it's taking quite some time, and now it plots a graph of everything against everything. Credit score against credit score গ্রাফ কেমন হবে, credit score against age এর গ্রাফ হচ্ছে এটা, রাইট? এবং দেখো ইন্টারেস্টিংলি হিউ এক্সিটেড দিচ্ছি যেহেতু সে এক্সিটেড কে 1 আর 0, 1 এর জন্য একটা কালার করছে, 0 একটা কালার করছে। সো আমি এখান থেকে এই যে গ্রাফটা দেখে বলতে পারছি এজ, দেখো এই পার্টিকুলার এজ এর লোকরা ইউজুয়ালি এক্সিট করছে, রাইট নাকি না? সো দিস ইজ 40 থেকে 60 এর মধ্যে অ্যারাউন্ড। আমি অলরেডি ফ্রম ভিজুয়ালাইজেশন দেখতে পাচ্ছি দিস ইজ আ চাঙ্ক অফ পিপল হু আর অ্যাকচুয়ালি লিভিং দি কোম্পানি, রাইট নাকি না? ইয়েস, it's more popular for young generation and for old generation, right nakina, right? But 40 to 60 age chunk of people actually are basically basically 40 to 60 a particular kind of people are actually leaving the company quite a lot. ঠিক আছে nakina? Yeah, so can you see that nakina? So এরকম করে প্রত্যেকটা পেপার you could see some interesting things. Look at here. So এখানে যেমন এটা হচ্ছে number of products, credit score against, I guess this is number of products. So if you see over here, that's number of products. So if you see number of products এর গ্রাফটা, you'll see যে products এর সংখ্যা 1 2 3 আর 4 হতে পারে। রিমেম্বার দ্যাট নাকি না? হ্যাঁ, products এর সংখ্যা কত হতে পারে? 1 2 3 আর 4। এই যে আমরা আগে ইনভেস্টিগেট করেছি, এই যে কোথায় নাম্বার অফ প্রোডাক্টস, it could be 1 2 3 and 4, ঠিক আছে, চারটা হতে পারে। And that's why you can see I can see 3 or 4, basically those who have 3 and 4 products, okay, they are the ones who are living mostly because these are all oranges, and orange is exited, right nakina? So you see, just this visualization can give you certain good idea about this particular data set. So it's always a good idea যে আপনারা এই data setটা নিয়ে you actually play with it, you do some visualization, okay, exploratory data analysis, right? And then আপনি যদি further data analysis করতে চান, you can do that. For example, here I plotted a count plot, ঠিক আছে? Age on the x-axis আর y-axis এ কি ড্র করেছি, y-axis এ কিছু না, y-axis এ count, ঠিক আছে? Age on the x-axis, and I'm taking the data from the data frame called raw data 2, and hue exited. Now, if I plot this graph, we get a graph like this. Wow, is it taking that much of time? Oh, yeah, it's done. So that's the graph. It just says, you know, orange color যেটা সেটা হচ্ছে exited. So exited যারা তারা হচ্ছে এই জায়গায়, okay? আর যারা exit করে না, এই zero, তারা হচ্ছে এই জায়গায়, right? So you see from the graph, I can tell age wise this is normally distributed যারা হচ্ছে exit করে গেছে, আর যারা exit করে না, this is more a right skewed distribution. If you know a bit of statistics, you probably would know what's a right skewed distribution, what's a normal distribution, right? Yeah. So graphs tells you a lot of interesting things about the data set. Always, whenever you analyze the data set, when you're finding something useful, keep it as a note, because that tells you a little bit about the data. So when you're writing the paper or things like that, you can actually say all these interesting things. That tells you that you know your data set, okay? You have looked into your data set, right? Clear? Okay. So similarly, I plotted a graph of number of products on the x-axis and the credit score on the y-axis, and I saw the same thing as I said over there. Those who have products of 3 and 4, they seem to have exited most. Okay, right? Okay, so these are the things we have seen. Okay. All right. How do you investigate the categorical plots? Now, we have got some categorical plots as well. So if you run this cell, you'll see there are some. So this is the raw data too. We found the head. There are some categorical variables. Categorical মানে কি? Categorical and numerical মানে কি? Numerical attribute মানে হচ্ছে with numerical values. Categorical attributes means they do not have numerical values. Like geography, this is what categorical values and numerical values. Hello? Categorical. So I'm just looking at what are the categorical features we have. Geography is one of them. Gender is one of them. What else? I can also say tenure is also one of them. Maybe tenure. Exited to sir is something that I'm going to predict. So the predict number of products coming categorical because it's very discrete. 1, 2, 3, and 4. ঠিক আছে, A B C and D এরকম হতে পারে, হ্যাঁ? Has credit card রাখতে পারি 1 and 0, ঠিক আছে? So I kept a list over here. So look at the list here. The list says geography, gender, tenure, number of product, has credit card, is active member. I keep it as a list, and the name of the list is cat features. ঠিক আছে, categorical underscore features. Then for F is one variable in cat features. So first of all, F is geography, then F is gender. So I plot a graph, and then plt.figure, and we plot a count plot. On the x-axis, we plot the particular feature, and the data is taken from raw data 2, and hue is exited, and I use a palette called set1. You could use a different palette. And when I do that, it plots different graphs. It plots, for example, here. It plots a graph here, like France, Spain, geography, France, Spain, and Germany. So we can see, let's say 0 is the 1 is the people, 1 over here is the people who exited. So we see the most who have exited are from Germany, compared to those who have remained here, right? So I can see another interesting, feature right now, or another interesting thing about the data set, that most people who have left the company are actually from Germany. The majority the people who have left the company are from Germany. You can say Germany যতজন মানুষ leave করছে, France, so it seems so. But yeah, there's a lot of people in France who've retained, but there's a few people in the Germany who've retained, right? So similarly, for each of these categorical plots, we have plotted a graph, so you can see males and females দেখতে পারেন. So some of them can actually give you some interesting information about the data. Some of them may not give you some interesting information about the data. Anyway, I think we'll stop here. Then we wanted to talk about how to do other pre-processing, but we just do not have time today. Okay? We'll see in the next class. Okay. But I would suggest you, I'll actually upload this, Jupyter Notebook. I'll suggest you go through this one, because for the next few classes, we will be going through this particular Jupyter Notebook, and we'll do different kinds of analysis using this particular data set. So it's very important that you have gone through the data set carefully. Is that okay, Nakina? Clear?